Good morning, sixth graders. So today we are going to continue talking about our expressions. Today we are going to start working on replacing our letters, our variables, in an expression with some numbers to help us solve it. And we are going to be doing that a lot with the area of a square, rectangle, different shapes. So let's take a look at our first exercise. So exercise 1 says to complete the table below for both squares. And it also says to note that these drawings are not to scale. Obviously, that teeny tiny little square is not 25 inches across. So let's start with the first square. So our first square, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 individual small squares. And we have this variable up here, s equals 4. So when we're talking about squares, s is equal to the side or the length of one side. So in this case, s is equal to the length of one square's side. So just one of those little squares. So to find the length of one whole side, we have 4, 4, 4, and 4. So we have to add all 4 of those together. So we have 4 times 4. We know that 4 times 4 is 16. So the length of one side of this square is 16. So the square's area, written as an expression, for this particular square, we're going to change that expression up a little bit. So the normal way that we would write this for a square would be 4s. I'm going to put that in the line or in the space for the second square, since that's what we're going to use for that second square. In this case, we have 1, 2, 3, 4 s's, so 4 sides that we have to calculate. So in order to find one side, we have to multiply 4s, but then we also have to add 4s plus 4s plus 4s plus 4s. So we still have that 4s, but we're going to put that inside parentheses, and we have 4 times 4s. Okay, so we'll have 4 times 4s. Now we're going to rewrite the area of that square written as a number. So in order to solve this, we'll have 4 times 4 times 16. So if you remember our order of operations, we're going to start with our grouping symbols with our parentheses in this case. And we have 4 times 16, which is 64. So we end up having 4 times 64. We multiply 64 times 4, and we get 256. So the area here is 256. Since we're talking about area, we would be writing this as the units squared. Since there's no units, I'm just going to write units squared. So when we're talking about area, our units are always squared. So now let's take a look at that second square that we have, the one that is 25 inches. So one side is equal to 25 inches. So this whole side is 25 inches. And our expression for the area would be 4s, or 4 times s. So to solve it as a number, we have 4 times 25. We multiply 4 times 25, and we get 100 inches squared. All right, so let's take a look at example 2. So example 2, we're going to talk about kind of what some of these different pieces represent, what they mean. So we have these two rectangles. We have one that has B centimeters on one side and 8 centimeters on the other side. And then our other rectangle says that one of these pieces is 4 centimeters in width and X centimeters for 2 of them. So our first question here is asking us, what does the letter B represent in this blue rectangle? So B is going to be this one. So B is the length of a side. And B is also equal to 8 centimeters. And it doesn't say it on here, but I do want to talk about what X means. So we're going to put X on there too. So X is up here. So I want you to think about that for a minute. And there's some different things that we can say about X. We could say that X is the side of 2 rectangles. We could say that X is equal to half the side of a rectangle, right? Because this rectangle has 1, 2, 3, 4 pieces, and X is 2 of them. So I'm going to say X is equal to 1/2 the length, or 8 centimeters. So we have a couple of different kind of what each of these things mean. Alrighty, so that's an important part here too, is to make sure we know what our variables are representing. Let's take a look at exercise 2. Exercise 2 says to complete the table for both rectangles. Using a calculator may be appropriate, so you're welcome to use a calculator if that is helpful for you. So we have 2 rectangles. I'm going to label these rectangles just to make it a little bit easier. So this first one with all the little pieces inside of it, I'm going to call A. And this one that has the measurements, I'm going to call B. So I'm going to put A and B. So for rectangle A, we don't have any units of measurement, right? There's no meters, there's no inches, there's nothing labeled there. So we're just going to call them units. So the length of this rectangle, so one side, so we're going to go from this piece to this piece. We have 1, 2, 3, 4, 5, 6, 7 units. So our length is 7 units. And our width is 1, 2, 3, 4 squares. So 4 units. And to write this area to write the area as an expression, I'm going to say length times width. So a lot of times when we write the variable L, if we use an L for a variable, we'll write it as a cursive L rather than a printed L, because a printed L can look like a 1. So you'll see me use a cursive L, so just that loopy L, so that I can differentiate between the two. So now we have the area as a number. So we have 7 units times 4 units. We have 7 units times 4 units, and that would give us 28 units squared. Then we have our rectangle B. So our length is our 46 meters. And our width, we have 32 meters. To write it as an expression, again, we can write length times width. And to write it with numbers, we have 46 times 32, or 46 meters times 32 meters. Sorry, let me rewrite that so we have our units. 46 meters times 32 meters. And this is where you're welcome to use a calculator if you'd like, or you can multiply it out. So we multiply that out and we get 1,472 meters squared. So the reason that we have our units squared for area is because we're multiplying the unit times itself twice. And as we know from talking about exponents, an exponent tells us how many times we multiply something by itself. So if we're multiplying meters times meters, we can write that also as meters squared. Example 3, let's take a look here. So we have some three-dimensional shapes here. So we have 3 questions that are asking about what these variables represent. And then the last question is talking about the formula for volume. So let's take a look here. We have L, we have W, and we have H. So L and W are both variables that we used before. So L, we know, is representing the length, and W, we know, represents the width. So now we have H. When we're talking about area, H is representing the height. All right, so if you notice, the H is what goes from the top to the bottom, the height. And it says, since we know the formula to find volume is V equals L times W times H, or volume is equal to length times width times height, what number can we substitute for L in the formula? So if we look at these pieces and we assume that these rectangular prisms are the same size and the same length and the same height and the same width, we can just compare straight across. So the length be equal to 6 centimeters. And then what other number could we substitute for L? We could also substitute 2 centimeters for L. We could even substitute 8 centimeters for L. The reason for that is because when we're talking about multiplication, we can move those numbers around however we need to or however we want to, and we're going to get the same answer. So those variables can represent any of those numbers. So it says, what number can we substitute for W in the formula? We could really substitute any of them, or we can substitute 2. And for height, we can substitute 8. But remember, we can really substitute any of them. Another reason we can do that is because if we took this rectangular prism and laid it on its side, the height would now be 6 centimeters. Or if we laid it on a different side, the height might be 2 centimeters. So it also depends on the position of the shape. So we can kind of interchange those 3 measurements. Let's keep going. So we have another table to complete. So again, I'm going to label these. So I'm going to call this one A and this one B, just so I can keep them organized. So I want you to go ahead and fill in as much of that table as you can, and then you can pop back onto the video and check your work. So I want you to go ahead and pause the video here, fill in as much of that table as you can, and then come back and check your work. Alrighty, let's take a look here. So for our shape A, our rectangular prism A, the length of our rectangular prism, I'm going to say is 12 units. The width, I'll say is 5 units. And our height, I'll say is 15 units. And our volume written as an expression, length times width times height. And then we can write it as a number. So we have 12 units, and I'm going to label that with U so I don't run out of space, times 5 units times 15 units. When we multiply all of those together, 12 times 5 times 15, we get 2,372 units, and in this case, cubed, or to the power of 3, because we have those units 3 times. We're multiplying units by itself 3 times. The way that I always remember it is units squared for area of a 2-dimensional shape, because a square is a 2-dimensional shape, and units cubed for 3-dimensional shapes, because a cube is a 3-dimensional shape. And then if we look at B, our length, we'll say is 23 centimeters. Our width, we'll say, is 4 centimeters, and our height, we'll say, is 7 centimeters. Again, our expression is length times width times height, and we multiply 23 centimeters times 4 centimeters times 7 centimeters. And we multiply that all out, 23 times 4 times 7, to get 644 centimeters cubed. Alrighty, so what we did today was we looked at some formulas. We looked at the formula for area of a 2-dimensional object and volume of a 3-dimensional object. And we substituted those variables for different units or different numbers, then solved for them. So if you have any questions about any of this, please make sure that you let us know, okay? Your independent practice, real quick, looks like this. You have a square to find the area of. You have a table, just like we've been doing. And then 3 says to find the perimeter of the quadrilaterals, or the shapes in the first 2 problems. Remember, the perimeter goes around the outside, so you're adding up all the sides. And part 4, or number 4, says using the formula for volume. Find the volume of a rectangular prism when the length is 45 centimeters, the width is 12 centimeters, and the height is 10 centimeters. So if it helps you to draw the shape out, you can do that, or you can just write it out and solve it. Alrighty. If you run into any questions or have any problems, please let me know or let Miss Sally know. We are both here and we are happy to help. Since this is recorded, we do not have a secret word today. So again, please let me know if you run into any problems or have any questions, and I hope you have a fantastic rest of your day. Have a good one, 6th graders.